Hello everybody, I'll be solving this question today regarding power factor. I have 120 volts RMS, 60 hertz source, and two parallel loads given here. First, I want to find the power factor of the two loads combined, and then I want to find the capacitance required to raise the power factor to unity. So let's start with part A. How will I find the power factor? Well, the power factor is equal to cos theta, where theta comes from the complex power, where S equals magnitude of S angle theta. But this is the total. So what I'll have to do is find, let's call this S total equals S1 plus S2. I'll find the complex power for load 1 and for load 2. Load 1. So load 1 it's giving me the power, 24 kilowatts. And theta 1, that's power factor 1, equals 0.8, and it's lagging. So I'll have to use a power triangle to solve this. I'll draw it here. So if I have magnitude of S, I have Q, P, theta. And how is power factor related here? Theta equals cos inverse of the power factor 1. And this will be positive because it's lagging. So cos inverse 0.8. 0.8 equals 36.87 degrees. And then what is my angle, or what is magnitude of S? So I'll use just my SOHCAHTOA and my power triangle. I have P, I have theta, so I can use cos, because that's adjacent over hypotenuse. Yes. So cos theta equals P over S. This is all S1, magnitude S1. Therefore, S1 is equal to P1 over cos theta equals 24K over cos 36.87 degrees. 24 over cos 36.87. 30K. And this will be volt amps. So all of this S1 is equal to 30 angle 36.87 degrees kilovolt amps. So that's for the first part. Now I have to solve for the second part. So for load 2, the same process. P2 was 40 kilowatts. Power factor 2 equals 0.95 lagging. Therefore, theta 2 equals cos inverse 0.95. That'll be positive because it's lagging. 18.19 degrees. And now I have to find my magnitude of S2. Same process as before, same equations I'll use. Cos theta 2 equals P2 over S2. I'm not going to rederive the equations. I derived them once. I'll just reuse them. P2 over cos theta 2 equals 40K over cos 18.19 equals 42.10 kilovolt amps. Therefore, my S2 equals 42.10 angle 18.19 degrees kilovolt amps. So now, there you go, went off the page there for a moment. So now S total is equal to S1 plus S2 equals 30 angle 36.87 degrees plus 42.10 angle 18.19 degrees. I'll just do this in my calculator. Equals 71.17 angle 25.95 degrees. Lagging because it's positive, that's fine. So, how do I find the final power factor? Well, theta total is just this here, 25.95 degrees. Therefore, power factor total equals cos theta total equals cos 25.95 degrees. Cos 25.95 degrees, 0.90 when I round it. Therefore, power factor is 0.90 and it's lagging because the angle is positive. So that's part A solved. Now let's go to part B. I'll get a new page for that. So for part B, we want to correct the power factor to unity because right now I have 0.9. So to get the power factor unity, I'll have to turn that into 1. So I will begin by the S total. I forgot to turn off notifications there. S total is equal to 71.17 angle 25.95 degrees lagging. So I need to find how much Q is there. And for my power factor triangle, I have S, Q, P, theta. So right now I have S and theta. But I need Q. So sine theta equals Q over S. Q equals magnitude of S sine theta. This will be 71.17. That's K. I should remember the units. Sine theta, 25.95 degrees. This will give me 71.17 sine 25.95, 31.14 kilovar. So this is, I'm going to call it Q old. So Q new is 0 because power factor equals 1. Therefore, Q old plus QC, because what I'm doing is in my power triangle, I'm adding this QC that'll negate the effects of Q, equals Q new. Therefore, QC equals negative 31.14 kilovar. So we know how much Q the capacitor has, but now we'll have to figure out what the capacitance is. So, for a capacitor, QC is related to the voltage across it squared divided by the impedance XC, and XC equals 1 over 2 pi FC. Using these two equations, I want C and I have QC. So beginning with the first one, I'll have to rearrange for XC is equal to V squared over QC, 120 volts RMS divided by, I'll make it the magnitude. I'll drop the negative sign here. 31.14 times 1000. Remember the 1000. So I have 120 squared divided by 31.14 times 1000. I get 0.4624. Okay, now going from this equation, rearranging this for C, C equals 1 over 2 pi f xc. Well, in this case, 1 over 2 pi, my f is 60, given in the equation, xc 0.4624. This all equals 5.74 millifarads. So I need a pretty big capacitor. Therefore, C equals 5.74 millifarads. There's my final answer for part B. So this is how you solve a relatively simple power factor problem. I'll just scroll through it one last time for you to see all the solutions. You can pause here to see what you need. Now, if you have any questions or suggestions for next videos, just let me know in the comments. Other than that, have a good one.